Hi, in this video we are going to talk about the implementation of the factorial problem, so let's get started. With the help of recursion, solving the factorial problem is quite easy and straightforward, I think. So we will have a public integer factorial method. We try to calculate the factorial of the n, and as you may guess, the factorial is just n times n minus 1 times n minus 2 up to 1. So for example, if we put 5, then the factorial is denoted with a exclamation mark, is going to be 5 times 4 times 3 times 2 times 1. Okay, so the base case, if the n is equal to 1, we are just going to return 1. And anyways, we are just going to return the n times the factorial. We are going to call this method recursively for the subproblem, of course, n minus 1. So if we... Okay, first of all, I'm instantiate the algorithm as usual, and algorithm system out println the algorithm that factorial for example 5. We should get, I think, 120. Yeah, 120. So it is working fine. There is a bit better solution, the so-called accumulative approach, and I'm going to create a public void fact. This is a so-called helper function. Here we specify that, okay, it is the n, and this fact is going to have two arguments, the so-called accumulator, and of course the integer n, the number we want to get the factorial. And I say that if the n is equal to 1, I'm just going to return the accumulator, and else I'm just going to call this fact recursively, and of course the accumulator will be the accumulator times the n, and I'm going to decrease the n by 1. And if the n is 1, I'm just going to, of course, I have to set it to integer. So the accumulator is going to store the actual value for the subproblem, as you may guess, and we are going to put the arguments back. And yeah, this accumulator stored the subproblem solution, and then whenever the n is equal to 1, it means that we can return the accumulator. So I'm just going to call the fact. Of course, the accumulator is 1 at the beginning, and the n will be okay. And of course, I have to return it. So whenever I run my algorithm for this, it's going to store the same. It's going to calculate the same. I want to calculate it for 8, then it's going to calculate it for me. So this is how we implement factorial. Thanks for watching.